Welcome back, reinforcement learning. This session I explain the drawbacks of the Q learning. Drawbacks of the Q learning. The Q learning is one of the method in reinforcement learning to estimate the rewards based on the state and action pairs. State and action pairs, we predict the rewards is called based on Q values. That is called Q values. We are using Q values as the limitations in complex environment to predict the rewards. So, we explored the issues, the Q learning failures in complex environments. These issues are solved by using distributional Q learning. Distributional deep Q learning concept we are introduced to solve the Q learning issues with complex environments. What are the issues faced the Q learning in complex environment to solve the problem? The first one is the loss of information. The Q learning typically computes a single point estimate. It calculates the average reward of the action state pairs. This approach discards the valuable information about the variability and distribution of rewards associated with the different actions. Okay, it is pointed on single point estimate. It is unable to calculate the variability and distribution of rewards associated with the different actions. So, we lost the information with the variability and distribution of rewards associated with the different actions. Okay, that is the one of the issue with Q learning. In environments where rewards can vary significantly, relying solely on the average can lead to misleading conclusions about the effect of actions. So, this is the one of the issue. For example, in medical scenario involving a new drug, a bimodal distribution of the outcomes might show that some patients benefit significantly while others see no effect with the same drug. The expected value fails to capture this diversity, potentially leading to the poor decisions. Okay, one is failure, one is success. So, the average is misleading the some potential information. This is the one of the issue with the Q learning. The loss of information. The second one is misrepresentation of rewards. The second issue and second drawback of Q learning is misrepresentation of rewards. By averaging rewards, the Q learning may produce Q values that are not representative of actual outcomes. For example, if the state action pair results in rewards of either plus 10 or minus 10, the expected value, the average of these two rewards plus 10 plus minus 10 is equal to average reward is 0. So, does not reflect any of the true observed rewards. So, this is the misrepresentation of rewards. In many real world scenarios, the real world scenarios, the rewards for a given state action pair may not cluster around a single value. Instead of, they may exhibit complex patterns such as the bimodal context. Treatment might yield a significant improvement for some patients while losing the some cases failures. It is the plus 10 and minus 10, plus positive and negative. The average is 0. So, the misrepresentation of rewards and inability to capture risk. It is not consider the variability and the distribution of the different actions associated with the state and actions. Inability to capture the risk. The traditional Q learning focus on maximizing expected rewards without considering the associated risk. It's not consider the remaining issues. Okay, it is mainly focused on the single point, only maximizing the expected rewards. It not consider the associated issues. So, this limitation can be particularly problematic in applications like healthcare, financial investments and autonomous driving cars, with the understanding into the variability and surroundings or associated issues is also considered in healthcare and financial investment and autonomous driving cars. So, this type of applications, the Q learning is failure to give the potential outcomes. So these are three of the main issues with Q learning. First one is loss of information, second one is misrepresentation of rewards, the third one is inability to capture the risk with associated issues. So for example, here the randomized drug trial in Q learning might predict the average reduction blood pressure as minus 13 mmHg. For example, the treatment group displayed the bimodal distribution with the peaks minus 2.5 mmHg and minus 22.3 mmHg. So the first one is minus 2.5, second one is 22.3. The expected value, the average of these two is minus 13 mmHg. This misrepresents the individual outcomes. So if the second one is low down to the 13, the first one is increased to the 13. So this is the one of the example for the drawback of the Q learning. The second is the transition to distributed learning. So we resolve these issues with the distributional Q learning concept is developed to resolve these issues of the Q learning. This is called a distributed Q learning out of these limitations by estimating the full probability distribution of rewards for each state action pair rather than just as the expected value. So key advantage, better decision making based when we are using distributed Q learning, we can choose the better decisions making and capture the multimodal distribution, revealing the diverse outcomes and enabling the more nonce policies. So it take the decision better compared to Q learning. And risk sensitivity, it allows the policies to account for variability. So it is consider the issues of the associated events. And empirical success demonstrate the superior performance in complex environments compared with the Q learning. It gives the better results with the DQN algorithms. For example, rainbow DQN algorithms give the excellent results with complex environments. The drawbacks, so the Q learning provides the fundamental approach in reinforcement learning. It relies on expected values, it has the limitations and it is not effective to solve the complex environment problems. So we are diverse into the distributional Q learning. It offers the powerful alternative for the Q learning to solve the complex environment problems. Thank you.